In the previous video, we looked at how we can explain machine learning models, the engine of AI. But when we're talking about machine learning in AI with classification, more often this is how it's thought of or worked, not with linear regression, but with also drawing a line. But instead of a line that gives the minimum distance from the line to the dots, we're looking for a line that, turn the pluses to a minuses, and let's get a line that is maximally distance from the dots, or find the maximum distance, or find the maximum distance from in this case, the blue circles and the green triangles. And that's going to be how we're going to classify our data with this. And we'll use this model to predict how to classify our data. So if we're doing part of speech, for example, let's say this might be verbs. So green triangles are verbs and blue circles are nouns. And we've gotten a bunch of data, obviously here, a bunch of words. I don't know what word this might be right here. Maybe that is chase, right? That's a verb. And we've labeled it as such, and so we know where it belongs on this chart because we've labeled it and we trained the model to recognize it. Now we want to use what we've plotted here, this information, say we've got more word that we don't know what part of speech it is. So instead of a circle or a triangle with a color, it's just some box to us. It's some word we haven't seen in our model yet. So we take that, and we're going to take the information that we use to create this plot here to plot where this word goes, this little box. So what are some information we might use to successfully plot and classify words in their parts of speech? Well, on the x-axis, we might do something like the word itself. We might have, right, we can assign a number to each word. If we do this cleverly, the words that are similar to each other in meaning will be close together, for example. Otherwise, just random numbers. But every word then on our language might have its own number. And let's say there's a place here for the word will. Let's say our word is W-I-L-L. And the computer doesn't know what that means. It just sees what the word is, and it sees that it has a place to chart that. And so it draws, it's going to be somewhere roughly on this line, but it doesn't know where. So that doesn't help us know if it's up above and it's a noun, or it's down below and it's a verb, a green triangle. So we need something more than just knowing what the word itself is, right? You could imagine that. Will could be my friend Will, which is a noun, or it could be will like a verb, though we might think of it more default. So we need some more information. So maybe we could look at whether or not, well, not whether or not, maybe we just look at other words. Let's say the word in front of this particular word. Let's say we can figure that out. And on the x-axis, then we chart what is the word that comes in front of this particular word in our text, right? And we know from the previous week when we learned about grammar that parts of speech is not determined by whether it's person, place, or thing. That's not really a reliable definition. Instead, it's determined by where it's distributed in the sentence. So that's what we want to know. Where is it distributed in relation to other words? So if we look at the previous word, let's say we have two examples. We've got will, let's say that's our box with 1, and then we have another instance in another place in the text, and that's will 2. Same word, but it happens, so different tokens. Same word from the dictionary, but it happens more than once in the corpus. We call those different tokens. And let's say for will 1, it's at the beginning of the sentence. So we look at the previous word at the beginning of the sentence. We look on our Y chart. Let's say there's a place here. Let's do the S there as the marker for the beginning of the sentence. Let's say it's there. So for will 1, that comes at the beginning of the sentence, we're going to chart. Let me do a different color here. We're going to chart then our y-axis, where that information is. You know what? My S here is very bad. I'm going to write that again. This is my beginning of sentence token. Okay. So knowing what the word itself is on the x-axis and knowing that the previous word or token is the beginning of the sentence, we now know that we can plot will 1, the first instance of this will, and I'm going to do a different color for that right at this right here. That's will 1. Aha. So that tells us the model is telling us that this instance of will is a noun. That's the one that was at the beginning of the sentence. All right. Our second will, let's say this one, it is also going to be on that up and down blue line there, but where should the purple line cross? Where's our x-axis? Well, we have to look at the previous word. That's what our x-axis is telling us. So we're going to look at the previous word, and let's say in this case the previous word is I. So it's I will. So let's say we look, if we've done this right, we would see I, the place for I on the x-axis, down here, the pronoun I. So we then would look and draw across and get to our intercept there, and we see that it is at that spot. So will 2, our second instance of will, should be plotted right here. Right here, will 2. So that tells us that this will, the model is telling us that this will is a verb. And if you think about that, that actually works out pretty well, because what would we expect if, what's the probability here? If a sentence starts with will, it could easily be like my friend Will, Will came, or Will went, or Will saw me. Yeah. Whereas if it comes after our second instance, was if it comes after the pronoun I, as in I will, it's very unlikely to be a noun, like my friend's name in that case. It's more likely to be a verb, the future verb, I will go, I will come, etc. So that worked out pretty well, just looking at those two features. And in fact, that is really the two most important features that a part-of-speech tagger that we design to do automatic part-of-speech tagging and tell the computer, figure out what these part-of-speeches are. Those are the two main features it uses. So this is a classification. This is the more common way of doing classification, where you draw the line as a separation, and you have more than one axis with features that you look at in your data, and it plots it there. And if it's on one side of the line, right, if it's above here, then that's going to be nouns, and if it lands below in this part, it's a verb, and you might have more categories, in which case you're going to need more lines. And another thing you may notice here is that, well, what happened to our predictions? And in the chart that we had before, our linear regression chart, we knew the X and we got out the Y. It was just one feature, and we made the prediction on the Y. So here, we've actually used two predictive features, right? Both our X and our Y are the predictions. Are the features. So where does our prediction go? Well, we actually have here a third dimension, which is the color. And the shape, that's actually a third dimension. We did this because it's easy to see on the slide. But if you really want to do this with math, you can't use colors and shapes. You have to use numbers. So we need to add a third dimension here.